so we're going to talk about frequency and histograms today. Okay, how many of you know what a histogram is? Nobody knows what a histogram is? It kind of looks like a bar graph, doesn't it? Okay, but it's not exactly. So, all right, we're going to go through and look at stem and leaf plots. Anybody remember stem and leaf plots? Okay. All right, and frequency tables. So a stem and leaf plot arranges data by dividing each data value into two parts. This allows you to see each data value. So for instance here, in a stem and leaf plot, you will see a number on the left side of the line and a number on the right side. Okay? And on the right-hand side of the line are only the ones digits or the last digit you'd be working with. Sometimes it's decimals. Right? But you only have one number on the left side where we could have more than that on the left, on the right side where we could have more than that on the left. So if you remember how to make them, then this should be reasonably easy then. So here they give us this set of numbers, and they want us to make a stem and leaf plot for those numbers. Now, what would be one thing we could do to make it easier? Okay, we could order them from least to greatest. So let's do that first of all, at least in this example to help us out. All right, so the smallest number we have is 8. And we have two of them, right? Okay, so let's see. I'm just going to list them right across this top here. 8, 8, okay. All right, let's see. So let's get rid of, we got both of them, okay. And we have 2 9s. Okay. What else? 12. All right, 2 13s. 14, all right. 15. 19, 20, and 21, right? Okay. So 19, 20, and 21. All right. Okay. So what do I do now then to make my stem and leaf plot then? What do I do? Wolverine, do you know? Okay. Well, you don't need to do any adding at this point in time, but yeah, we're going to take, if any numbers that we have, only the last number or the last digit goes on the right-hand side. But the big thing is what's going to go on the left-hand side. Okay. All right. So we're going to put on the left-hand side, there are no numbers in front of there's only 8s and 9s, right? What do I do to represent the number there then? Matt? 0. Okay. So we're going to put a 0, a 0, and then we need a 1, and then we need a 2. All right, so this represents all the 1s digits, the 10s, and the 20s. Okay. So then I'm going to put 2 8s, 2 9s. Do I separate them with commas? Kylie? No, why not? Okay, she's not sure. Why don't we separate those with commas? Okay, so nobody knows. The reason we don't is because we know that every one of them only represents one number. This does not represent 8,899. It represents an 8, an 8, a 9, and a 9 because it's just those 1 digits. All right, they go with the 0. Okay. Same with here. We have 2, 3, 3, 4, 5, and 9. Okay. We don't need to separate them with commas because we know they each represent 12, 13, 13, 14, put a 0 and a 1 down here. So these are the number of defective widgets in a batch of 1,000. What's a widget? Charlie, you know what a widget is? No? All right. So there's our stem and leaf plot. Now sometimes you have to make, we have double or what they call back-to-back stem and leaf plots if there's more than one set of data. Here the season scores for the football teams going to the state championship are given below. I should say Team Warrior, right? Not Team A. Right? Team A and Team B are listed. Now, so the first thing we could do is when we write those down, we could write them down in order, right? From least to greatest to help us to put them on our stem and leaf plot. Do we need to do that though? Not necessarily. We can if we want, but we don't have to. How many of you would prefer it that way? Okay. All right. Okay. How many of you really don't care if it's that way or not? Okay. All right. So it doesn't matter. If you do prefer them in order, then go ahead and put them in order. Okay. I'm not going to. Now, with a back-to-back stem and leaf plot, labeling becomes important. All right? So do you want to put Team A on the left side, or do you want Team A on the right side? What do you think, Kylie? On the left. Okay, so we're going to put Team A here on the left. This will represent their scores, and Team B on the right will represent their scores. So now, since they're all two-digit numbers, we need to list all the tens values down the middle. So let's see, the smallest number we have is what? And we're looking for both sets of data, not just one of them. 37. So we need a 3. Okay. All right. And then what's the largest one? 72. All right. So we need a 3, 4, 5, 6, and 7. We need to represent all of those tens digits. Okay, from the lowest number to the highest one. Okay, so we'll start with Team A. Now, whenever you're working on a back-to-back stem and leaf plot, we always work from the middle out. Okay, so the smaller numbers are going to go closer to the line. So for Team A then, let's see, we have 42, 42, 45, and 49. So we need 2, 2, 5, and 9. So we've got, all right, so we go to the 50s. There's a 55, 56, and 58. So 5, 6, and an 8. And they have a 61 and a 65, and then a 72. All right, and then for Team B, they have a 37. Let's see, in the 40s, 48, 49, 48. So 2 8s and a 9. In the 50s, they have 52, 57, 58. So 2, 7, and 8. And then they have a 60, 61, and 63. So how many of you remember how to do that now? Right. Okay. Easy stuff, right, Morgan? Very good. Okay, so stem and leaf plots are one way of displaying data so that you can see all the numbers that are represented. We can also make frequency tables. And for the frequency table, I have a little more detail here that we'll write down. So a frequency table, or the frequency of a data value, is the number of times it occurs. Frequency table shows the frequency of each data value. So if the data value is divided into intervals, the table shows the frequency of each interval. So sometimes it's not just a single interval or a single value. Sometimes it's a group of values, like the numbers 20 to 25, 26 to 30, or 26 to 29. But each of your intervals that you choose all have to be the same width. You can't do 20 to 23 and then do 24 to 30. Okay, they have to be the same. Here we have the number of students enrolled in Western civilization classes at a university are given below. Use the data to make a frequency table within intervals. So it says here's some steps to be able to do this. Step 1 says identify the least and greatest values. So what's the smallest and largest numbers up there? 9 is the smallest, all right, and 32 is the largest. Okay. Now it says to divide the data into equal intervals. For this data set, use an interval of what? Okay, how many intervals, how many pieces of data do we have? There we go. 1, 2, 3, 4, 5, 6, 7, 8. Oops. 2, 4, 6, 8, 10, 12. Okay. So we want to have equal intervals that go between 9 and 32, don't we? Okay. What would be some good numbers to use for that? Or how wide of an interval should we have? Would going by 2s be okay? Or should we use 3s or maybe 5s or 10s or 20s? What do you think? So one of it is that from 32 to 9, let's think about from 32 to 9. How far is that? 23, right? Okay. Now, if I have 23 values, okay, between 9 and 32, okay, what would be a nice even number to divide that up into? If we divide by 3s, 23 divided by 3 is about 8, right? Okay, 24 divided by 3 is 8. So 23 divided by 3 would be pretty close to 8. So do we want 8 different intervals that we're going to be working with? Or should I have fewer than that? Okay, it kind of depends on how many pieces of data I have. We don't have a lot of pieces of data. With 12 pieces of data, there's not a lot there. Okay, so we don't want our intervals to be too big or too small. So what do you think would be a good number for the width of them? What if we use 5? How many intervals would I need for 5? Okay, so we would need 5 of them, right? If we have more than 4, we need 5. Okay, so let's try 5s. So my starting one is going to be where so that I have 9 in there? Should I just start at 9 and go 9 to 14? Or should I start at an even number and go? Should I start at 5 and go to 9 and then do 10 to 14? Should I start at 9 and go to 13 or 14 and then go from there? What should I do? Now we want easy numbers to work with, right? What are easy numbers to work with? Okay, fives are easy, evens are easy. Okay, if we go by evens, we're going by twos, and there's going to be too many of them then. Okay, but if we go by fives, all right. So if we thought about this, we would end up going from, we could do like from 0 to 4, right? That would be one interval, but there's none in there, is there? 0 to 4. Okay, how wide is this? Is that 4 or 5 wide? Okay, it's 5 because we got to count 0. 0, 1, 2, 3, and 4. Okay, so we don't need that one. So we'll start at 5. Go 5 to 9, and then 10 to 14, 15 to 19, 20 to 24, 25 to 29, and then let's need one more, 30 to 34. Okay, we use those for our intervals. Then when we're doing a frequency table, we just need to put in how many are in each interval. Right? So how many numbers are there between 5 and 9? The number 9, right? So there's 1. In our data set, Nolan. Okay. How many between 10 and 14? So we have 1 and 2. 15 and 19? 1, 2 there. About 20 to 24. It's going to be 2 there. And 25 to 29. 3. Okay. And then 2 in our last one. Oh, we split that up pretty good then, didn't we, by doing it that way? Okay. Now you could have started, you really could start anywhere, but it's nicer to work with numbers that have intervals that we're used to working with, like, even numbers or working with fives and like that. So you notice, though, that the start of each interval was 5, 10, 15, 20, 25, and 30. So we started each interval here, and then to get 5 numbers, then we stop just before it. Okay. And that's our frequency table right there then. Okay. So let's make another one. Here are the number of days of Maria's last 15 vacations are listed below. Use the data to make a frequency table with intervals. Now, once again, in making this frequency table, you have to find the least number first, the smallest number, and the largest number to start with. Okay, so the smallest number is 4, and the largest 15. So to go from 4 to 15 then, how wide should our intervals be then? Should we use fives again? Okay. So how many, if you use fives, how many How many intervals are you going to have? Okay, just 3 different intervals. Okay, so you went, what were your numbers then, Megan? Okay, all right. You, you can't end and start on the same number. Okay, so if you're going to do that, you would have to go 0 to 4, 5 to 9, okay, then 10 to 14, and then you have to do 15 to 20, or 15 to 19. Okay, you can do that, but when you make your interval, the last number has to be different than the first number that starts your next interval. Okay, but that works. That'll work. You can do that. All right. What's another idea then, Dylan? Mm-hmm. You would count that as 2 pieces of data. Okay. All right. So she went by 5s. Anybody else? What's a different amount you could go by? Mitch? 4. You could go by 4s. Okay. That would work also. Okay. So what numbers are you going to use? Okay. So you're going to start at 4 then. Okay. So he could go 4 to 11, 4 to 7, 8 to 11, 12 to 15. Okay. All right. You could do that. Okay. You could do what Megan did. Okay. We could go 0 to 4, 5 to 9, 10 to 14, 15 to 19. Okay. It's kind of going to be a little personal preference which one you do. You normally want, you could have 3 to 5 different ones. You could have, up to 7 different intervals, but you don't want a lot of different intervals, so you want to keep it, so where that's narrowed down somewhat, because you don't want too many pieces of data. All right. So if we did Mitch's here, then we would have, let's see, 4 to 7, we've got 1, 2, 3, 4, 5, 6, 7 pieces of data there. And 8 to 11, 1, 2, 3. And 12 to 15, we have 1, 2, 3, 4. Okay, all right, that works. And if we use Megan's, from 0 to 4, we have 2 of them. 5 to 9, we have 1, 2, 3, 4, 5, 6, 7. 10 to 14, 1, 2, 3, 4, 5, and then 1 in that range. Okay. Do both of those work? Yes, they will both be fine. We can use either one of them. You could go by 3s. If you want a little bit more, if you want more intervals, you could go by 3s. We could start and go 4 to 6. Okay? But where you start is up to you then. Okay? All right. Histograms. Histogram is a bar graph used to display the frequency of data divided into equal intervals. The bars must be of equal width and should touch but not overlap. Now you notice when we actually did bar graphs, okay, notice with the bar graphs there's space between them, right? Okay. With a histogram there's not space between them unless there's an interval where there's no data, right? They have to be touching. So here's our numbers we use in example 2 about the classes from Western civilization. So let's take that data that we used. Let me find this histogram here. So let's go. Let's see what all I can copy here. I want a picture. So here's our histogram, or our frequency table. We're going to use this frequency table to make a histogram then. Okay? So we have to, when we make a histogram, we have a horizontal bar and vertical. On the vertical, we have evenly spaced numbers, and on the vertical is what our frequency goes here on the vertical. So we have 1, 2, 3, 4, 5. This is the number of pieces of data I have. Along the bottom, we're also going to have evenly spaced, and we need how many? We need 1, 2, 3, 4, 5, 6 of them. So we need to have enough for 6 different intervals here. So when I number this, then I'm going to start with, this is going to be 5, 10, 15, 20, 25, 30, and 35. Okay. So basically, so my starting values here are going to be the starting values of my intervals. And then we make a histogram. And with our histogram then, that means our bar, so we make our histogram from 5 to 9, we went up 1. So I go up here and over, and we stop just before we get to that next one. Okay. So it goes to 5 to 9, it doesn't go all the way to 10, right? Okay. All right, and then from 10 to 14 we have 2. From 10 to 14 we have 2. Oops. That's ugly, isn't it? 15 to 19 we have 2. So this bar is going to be the exact same height, exact same width, hopefully, if I did my work right. That's why I gave you graph paper, so when you make them, you can use the graph. Right. From 20 to 24 is 2 also. '25 to 29 is 3. And 30 to 34 is 2. Those should all be touching when you do them. You guys remember how to do those then? Okay. Piece of cake, right? So let's go back here then, and I want you to pick, or if you use different numbers, so you can pick either Mitch's numbers here, or Megan's, and make a histogram that goes with those numbers then.